A tool working once is only the starting point. Before production, we need evidence that it behaves correctly, protects data, handles failures, and makes sense to AI clients. This lesson is about testing for real-world confidence. Let's connect where we are. We've built the MCP foundation, added the security model, and designed tools with clear schemas, validation, outputs, and failure behavior. Now the question shifts. Do those choices actually hold up when real clients and agents use them? MCP testing needs a broader mindset than traditional API testing. First, the tool contract must be clear and enforceable. Names, descriptions, schemas, validation, and outputs. Next, the implementation has to behave correctly under real conditions, including retries, failures, mutations, and rate limits. But correctness alone is not enough. The tool must also respect authentication, authorization, tenant boundaries, and secret handling. And because AI clients call these tools, we test agent usability too. Can the model choose the right tool, provide valid arguments, and avoid unsafe actions? Quality comes from all of these layers working together. Before a tool handler talks to real systems, prove its logic in isolation. Use controlled inputs and mock dependencies, so each test starts from a predictable setup. Then invoke the handler the way the runtime would, and assert the structured response: status, data fields, error shape, and expected side effects. Good coverage includes happy paths, missing fields, invalid types, malformed payloads, and boundary values. Keep each test focused on one behavior, so if something fails, you know the handler logic broke, not the network or database. Contract testing treats every schema as a promise between the MCP server and its clients. Tests should prove that valid inputs are accepted, invalid ones are rejected, and errors are predictable. They should also verify that responses match the documented shape, required fields, types, enums, nested objects, arrays, nullable values, and defaults. The key habit is testing both normal and awkward cases, because agents often depend on exact structure. When a schema changes, contract tests act as an early warning system, catching breaking changes before they become runtime failures. Integration tests move beyond the handler and prove the adapter really speaks the backend's language. A call like search tickets or list invoices should build the right query, apply filters and sorting, respect pagination, and enforce result limits. Run these checks against realistic infrastructure when possible, or high-fidelity mocks when necessary. Seed test data deliberately. Full results, empty results, partial availability, and failure cases. The most important assertion is not just success. Backend failures must be translated into safe, useful MCP errors that clients can act on. Authorization testing is about proving the boundary holds, not just confirming the happy path. For every sensitive operation, define who should succeed, who should fail, and why. Test roles, scopes, ownership, and tenant filters separately, because each can break in a different way. The negative cases matter most: cross-tenant reads, unauthorized writes, and attempts to upgrade privileges. A good denial is safe as well as clear. It creates the right audit event and avoids revealing record IDs, tenant names, or internal policy details. For mutation tools, the question is not only did it work, it is what happened when it worked twice, failed halfway, or retried after uncertainty. Start from a known state. Make the mutation with an idempotency key. Then simulate a timeout after the backend may have changed. Retry with the same key and assert that the final state changed exactly once. Also verify that invalid arguments and unauthorized callers are rejected before any side effect occurs. Finally, check that the audit trail records the actor, the change, and the reason, so recovery is explainable. Reliable MCP behavior is defined as much by failures as by successes. Test each failure class deliberately. Bad input, missing permission, not found, conflict, timeout, and downstream outage. Then decide what the client should do next. Some errors invite retry, such as a temporary dependency failure. Others should stop immediately, such as forbidden access or invalid arguments. Rate limit and overload tests are especially important because AI clients may retry, chain tool calls, or request too much at once. The goal is safe degradation, clear guidance for the client, no sensitive details leaked, and no cascading failures under pressure. Prompt injection testing asks a simple question. What happens when hostile instructions arrive disguised as ordinary data? A support ticket, email, search result, or document might say, export all secrets or bypass policy. Place those strings inside tool arguments, resource content, and metadata. Then verify that the tool treats them as data, not commands. The critical control is server-side enforcement. Safety cannot depend on the agent choosing wisely. Unsafe calls must be denied, sensitive outputs redacted, and returned content clearly scoped so downstream agents can distinguish information from instruction. Abuse testing asks, what if a valid request is still unsafe? Start by pushing query scope. All customers, full exports, or open-ended date ranges should be rejected, capped, or require explicit approval. Then test writes. A tool call with perfectly formatted arguments must still fail if the caller lacks permission. Finally, treat every response and log line as a leakage surface. Look for tokens, credentials, internal IDs, stack traces, and sensitive fields. The safest default is minimization. Return only what is needed, redact what remains, and make unsafe access visible in audit logs. Agent behavior evals test the full decision loop, not just whether a tool call succeeds. Start with a realistic user request and ask, should the client call a tool, which tool, and with what arguments? Strong arguments are valid, minimal, scoped to the task, and allowed by policy. Sometimes the best response is not a call at all, but a clarification question. These evals should also catch overreach, such as unsafe writes, broad searches, or pulling more data than needed. The goal is to prove that the agent can use MCP tools with judgment, restraint, and accuracy. Good evaluation scenarios feel like real users, not toy prompts. Cover the normal request, the edge case, the adversarial trick, the ambiguous ask, and the case where the agent should not use a tool at all. For each scenario, define the test data and expected behavior. Which tool is called, what arguments are passed, how results are handled, and what final answer is acceptable. A golden trace is the known good path. Future runs are compared against it, so regressions show up as changed calls, wrong arguments, or unsafe tool use. Testing should be part of delivery, not a separate checklist at the end. Every commit should trigger fast unit and schema checks, so broken contracts are caught immediately. Before code merges or deploys, run deeper integration, authorization, and abuse tests against realistic workflows. For agent systems, evaluations must also run when prompts, schemas, models, or tool descriptions change, because behavior can shift without code changing. Finally, define release gates for non-negotiable failures, unsafe writes, data leakage, cross-tenant access, or critical regressions. If those fail, the pipeline stops. The big takeaway is that MCP testing goes far beyond happy paths. Reliable tools need verified schemas, handlers, adapters, authorization, side effects, errors, and security boundaries. We also test how agents choose tools and recover safely. With that foundation, we're ready to move into production. Observability, deployment, scaling, runtime configuration, and governance.